Good evening, Moksha. Moksha, good evening. Just let everyone join. Give me 1 minute till everyone joins.
Good evening, sir.
Yeah, good evening. Okay, so this is your chemistry class, and today we have completed metals and non-metals. We'll continue with carbon and its compounds. So, however, we had started with carbon and compounds once. Today we'll continue with that chapter. Okay, but we'll start from the beginning of the chapter, carbon and its compounds. All right. Okay. So, for chapter light, let's continue. Okay, see.
Sir,
Yes, Abhinav.
sir, is it chemistry or
Chemistry. Monday and Wednesday it's chemistry, and Friday and Saturday is physics. So today we'll continue with carbon and its compounds. I think that's the last chapter from this chemistry. Okay. Or if you want any assignment to be done from metals and non-metals, we shall do. So what chapters you are left with? In chemistry, you are left with carbon and compounds, and in physics, you are left with the electricity and magnetism. These are the two chapters which you are left with. Okay. So I think we shall start with carbon and compound. The chapter is a long chapter, and most probably by I think by the end of November, you people will start having your those exams, have pre-board exams. Am I correct? You will start having your pre-board exams over that. So carbon and its compounds. So the chapter is quite easy. Just pay attention to everything. It would be easy. Okay. Carbon and its compounds. So first of all, why to study carbon? Why we are going to study carbon only? Why we don't choose any other substance? Why we are
because of
choosing?
its versatility?
Yeah,
Because of its versatility to combine with more elements.
yeah, because of its versatility. Of course, we can add it. So this is because of its versatility.
Good evening, sir.
Yeah, good evening. All right. So carbon and its compounds. Let's try to study first carbon. See, carbon is very closely related to our life. So first of all, carbon is versatile. What do I mean by versatile? Yes, Moksha, what do you mean by versatile? When you say carbon is versatile, right? See, carbon has a number of uses. It's available in a number of forms. Okay. In our body makeup also, we see all compounds like glucose. amino acids, everything all being made up of carbon only. So carbon is versatile. That is why we need to study about carbon. Then second thing, the second property of carbon which we are interested in is its catenation. So carbon is the, out of all the elements, carbon is the only element which can show catenation. That means catenation, it is the ability, to form long chain bonds, with itself. Okay. So what is carbon? Carbon is versatile. It shows the property of catenation. That means it has the property to form long chain bonds with itself. So these are the different reasons because of which we study carbon. Some things we'll also see as allotropy. So these are the things which allotropy. So Abhinav, what is allotropy?
The ability of element to exist in different states.
Good
Yeah,
evening, sir.
the ability of an element to exist in different physical states. The property of an element to exist in different physical states at similar conditions, at same conditions of temperature and pressure, of temperature and pressure. So under similar conditions also, they exist in different physical forms. So this property is called as allotropy. For example, we see allotropes of carbon, we see allotropes of sulfur, we see allotropes of phosphorus. Okay, just 1 minute. All right, thank you for informing. This is versatile. It's versatile. Now it's okay. And I think I should make a little bit of more correction here. All right. So understood all of this. Why carbon is so important? Why we are studying carbon? So first of all, it is versatile. It's available everywhere in a number of forms. Its property of catenation, that is, it has the ability to form long chain bonds with itself. Carbon shows the property of allotropy, that is, it can exist in more than one physical forms under similar conditions of temperature and pressure. Okay, so that is allotropy of carbon. Along with allotropy of carbon, different other elements also show allotropic, like sulfur also shows allotropy, phosphorus also shows allotropy. There are two allotropes of sulfur, which are called as monoclinic sulfur and rhombic sulfur. So we'll first of all we start with physical properties of carbon. Since we are doing with the physical properties of carbon, we must first look at, before going about physical properties of carbon, we must look for its allotropy first. Okay. So for carbon, I just seen that carbon exists as two forms. Right? Okay. For everyone, this information is for everyone. I just received an update. So all of you, I give you just 1 minute. You choose any picture as your background picture as you wish. You can choose your cartoon, you can choose your wallpaper, whatever you want as a background image, but all your cameras should be on for everyone. This is for everyone. For everyone, your camera should be on. And set your background image or whatever you want to do, you do that. So if you are here, just so that I can see you are there. All right.
Sir, my camera is not, it's like not working.
Can you inform in the feedback group, support and feedback group? Are you there?
Yes, I'll tell him. Okay,
Okay,
sir.
message in the support and feedback group so that ma'am will be able to know.
Okay, ma'am.
Anyone who is having such type of issue, please inform in the support and feedback group. All right. So see. Dhairya, have you informed? Oriya, Ishak, Moksha. All right. Sudhamshu. Sudhamshu, Dhriti, Shubhansh.
Yes,
I
sir.
can't see your. Okay. I can't see your cameras.
Sir, 1 minute, sir. I'll tell.
Dhriti.
Yes, sir.
Okay. So you can't turn your video. Please message in the support and feedback group. Message in support and feedback group so that ma'am will be able to correspond accordingly. She will be able to check with the parents what is the update about it. All right. Not yet.
Okay, sir.
Sumukh. Sumukh. Are you there?
Yes, sir.
So
Yes,
please
sir.
turn on your camera
So
and
my
don't keep
camera is
it off. Yeah.
sir, my camera is not working. It doesn't detect to the.
So have you informed in the group, support group?
Yes, no, sir. I should
Please
tell it.
inform there. Please inform there
Yes,
so
sir.
that ma'am will check it accordingly. Inform in the feedback support group.
Sir, support group.
Yeah, in the support group.
Okay, sir.
In the support group, inform that I'm not able to turn on my camera, mic not working or whatever, speaker not working, camera not working. Inform there.
Yes,
All
sir.
right. Okay. So see physical properties of carbon. So to study the physical properties of carbon, first we see the allotropes of carbon. Right. So Moksha, what are the allotropes of carbon?
Diamond, graphite, and Buckminster fluorine.
Which one?
Diamond, graphite, and Buckminster fluorine.
All right. So diamond, graphite, and Buckminster fullerenes. So which are the natural allotropes?
Diamond and graphite.
Yeah, diamond and graphite are the natural. They are the natural allotropes. And what is the difference in their properties? Arav, can you tell the difference between the properties of graphite and diamond?
Sir, diamond is much harder than graphite.
Diamond is?
Much harder than graphite.
Yeah, diamond is harder than graphite. Very good. And any other?
Graphite is a better conductor than diamond.
Graphite is a good conductor of electricity, whereas diamond is not. So diamond is not a good conductor, whereas graphite is a good conductor of electricity.
Sir,
So these
does
are the
luster count?
luster. All right. Diamond is lustrous, but graphite is not. Graphite is opaque. Diamond is transparent almost. All right. So these are some of the differences. So first of all, we will look why diamond is hard. Diamond is hard because of its tetrahedral structure. So just remember the word tetrahedral shape. or you can say because of tetrahedral geometry. The geometry of diamond is tetrahedral. I'll show you how does a tetrahedral geometry look like. So in 3D, a tetrahedral geometry looks something like this. You can observe here a tetrahedral geometry. See, it's good to see it in 3D. Okay, tetrahedral geometry. Uh, this is what your tetrahedral geometry looks like. So you have four molecules arranged in three-dimensional space. See, one atom upward, three atoms over here. And the point is that if you rotate it anyway, at every time the angle between any of the bonds will always be 109.5. This one is away from you, this one is towards you, this one is here. Okay, so everywhere the angle between all of them is always 109.5 degrees. Okay, I'll just show you one more thing about this. This is tetrahedral geometry. Just one minute. Let's see. Yeah, see, if you rotate a tetrahedral geometry in 3D, so this is how see it looks like. Everywhere the angle will just be 109.5. Even if you flip it, so then also it would remain the same. Okay. So for a diamond, the carbon atoms, they are joined in the form of tetrahedral geometry. They are joined like this. So carbon at here is joined to three other carbon here and one carbon at the top. Okay. So everywhere, even this angle is 109, this angle is 109, this angle is 109. The bottom angles between any of them, the angle between these two is also 109.5. Got this? So such a geometry of is there for a carbon atom, which we call as the tetrahedral geometry for diamond.
So
So
how
this,
do we measure it?
how do we measure it? Yeah. So there is an X-ray diffraction method for measuring the angle between the bonds. All right. There is electronic diffraction method. There are different methods which are employed to measure the bond angles. Okay. So you measure the bond angle between the carbon and carbon, which is 109.5. Got this? So for diamond, the structure is something like this, which is very hard. Now assume another carbon bonded to this again in the same way. So it continues. This is just one chain. After this, there will be another chain. There will be another chain of this tetrahedral. So this gives it a rigid structural shape, a hard, rigid structural shape of a diamond. Okay? So this is a diamond. In the same way, if you observe this uh, hexagonal shapes for graphite. So the for graphite, also there are four bonds. So all the four bonds, they are not the same. There are three bonds which are three bonds of the graphite. They are like this. Mm. Okay. So for graphite, if you observe, it has a hexagonal planar geometry. This is geometry of graphite. So you have a free electron. Always there is a free electron. Just one minute. Yeah, like this. So see here, you can see there are a number of carbon atoms which have been linked to three carbon atoms. Every carbon atom here is linked to three other carbon atoms, and they are forming layers. So here two layers have been shown, and these two layers, they can slide. They are movable. So there is one electron which is not bonded. There is one electron which is stationary, which is free. Every carbon has four electrons. Yeah. Okay. So understood this tetrahedral, this geometry of graphite.
Yes, sir.
Just 1 minute. I want the real image of it. Let's see. For graphite. Yeah. So you can see hexagonal plates here. See here. Every carbon here, each of the circle, it represents a carbon. So you can see every carbon is connected with other carbon atoms, which are 3 in number. So it is connected to 3 other carbon atoms. Right? So every carbon atom here is connected to 3 other carbon atoms. You can see there is no carbon atom which is connected to 4 carbon. However, the number of electrons which are available for bonding with carbons, the number of available electrons is only 3, 4 electrons. So we can say that one of the electrons of each carbon is not bonded; it's free, which helps in the conduction of electricity. And since the bonding is not that strong, therefore, therefore, the graphite is not hard; it's soft. All right. So understood about these two, allotropy. The next week, versatility of carbon we have already discussed. Versatility means
Sir, 1 minute, sir. Writing, sir.
done.
Sir, 1 minute, sir.
Huria Ishaq, what do you mean by versatile nature of carbon? Huria Ishaq, are you there? Yeah, Huria, are you there?
Complete it, sir.
Okay.
Sir, that is
So,
buck. What is that, sir?
Bhatti?
Buckminster full ring.
Yeah, it's Buckminster full ring.
Okay, sir.
If I need to spell it, if FULRENES, full rings. Like this. Buckminster full rings. Okay. So see, versatility means carbon is available everywhere in the form of glucose, in the form of amino acids. That is all the proteins which we have. Our body is made up of proteins. Cells are made up of proteins. So the amino acids or the proteins, they are made up of carbon and nitrogen. They are the products of carbon and nitrogen. Alright. You have fatty acids or fats. So the fatty acids, they are also made up of carbon. So our completely carbon is very closely related with the living organism. Alright. So next we see catenation. It is the ability of carbon to form long chain bonds with itself. So carbon has the ability to form long chain bonds with itself, which we call as catenation. So here we will observe two types of we have three types of catenations. First, we'll see a formation of chain. Then we'll see formation of a branch. Last, we will see the formation of a ring. So with the help of catenation, carbon is able to form all this. Carbon is able to form a chain. So there will be a long chain of carbon atoms linked to each other. Okay. So there can be hundreds or thousands of carbon atoms which are linked with each other. So you can really see that there is one molecule which contains about 100 or thousands of carbon linked with each other. So such are the chain compounds of carbon. You can also obtain some branched compounds like this. There can be a chain, and in that chain you can observe a branch over here. So this can be another chain. So here you can observe another branch. So on it can be there. Here also you can observe another branch now. So such compounds, they are the branched compounds. So these are the branched, these are the chains, and then you have rings. So at some places, the carbon and carbon, they may combine with each other in the form of a ring like this. So you can have 4 carbon also combined with each other in a ring. You can have 5 carbon also combined with each other in the form of a ring. Like this one. You can have 6 carbon atoms also. So carbon atoms, they can be combined with each other in a number of ways. Okay? They can show catenation. Got it, everyone?
Yes, sir.
Yes. Any doubts up to here for anyone?
No, sir.
No, sir.
No. All right. So we have studied about catenation. We have studied about versatility. We have studied about allotropy of the carbon. We'll see allotropy in the case of sulfur also. Let's see how does sulfur show allotropy. So allotropy of sulfur and phosphorus. With this will end up the physical properties of carbon. Allotropy of sulfur and phosphorus. So sulfur forms two types of allotropes. It has monoclinic sulfur. It has monoclinic sulfur and rhombic sulfur. So one of them, so sulfur is is a molecule of 8 atoms, where one of them is in the form of a crown, whereas the other one is in the form of a boot. Okay. So their structures are like this. One of them forms structure like this, a crown. Okay. Fine. So this forms a crown. So here it's like this. It looks something like this. I'll show you. So the sulfur atoms, they are linked with each other, giving rise to the shape of a crown. So such a shape, this shape is of a crown shape. Okay. The other arrangement of the sulfur molecules will give us the structure like a boat. So it's like this. 2, 5. Just 1 minute, let me draw this. So this structure of sulfur is like this. Okay. Draw. Give me 1 minute. I'm drawing it. So this one which we have drawn, first one, this is the structure of the rhombic sulfur. Okay. Similarly, you will have the structure of monoclinic sulfur which appears in the form of both. So this is like this. Yeah. One, two, three, four, 5 and 6. Let's say there are 6 only. I thought there are 8, but there are 6 only. So this is a boat arrangement. So such a structure. This is one of the arrangement of one structure. Got this? One, two, this first one. There have to be 6, right? So I'll just you get another here, another here, and then link that. So it's linked like this. Yeah, this way. So this way you have another sulfur. This is monoclinic sulfur. Got the two structures? This is monoclinic, and this one is rhombic. So rhombic sulfur. Okay. So with this, I think we have finished with the physical properties of. We have finished with physical properties of uh, carbon. Let's see. So even if your course gets completed, okay, even if your course gets completed, we'll start solving some of the CBSE based questions, or we'll just increase the level of the questions. So currently, whatever questions you see, they are not that too high level; they are very low level questions. Okay. Once we are done with the syllabus, we'll start this. See what all we have done. We still have to do the bonding between the carbon, which is a covalent bond. So that we have to do. Covalent bond we haven't done. We have done the physical properties. First, then we'll do the covalent bond. Yeah, versatile nature of carbon. This we have done. Versatile nature of carbon. So carbon has the unique property, unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called as catenation. So we have discussed the property of catenation here. And the second point, since carbon has valence of 4, so it is capable of bonding with 4 other atoms of carbon, and hence carbon can easily combine with oxygen, hydrogen, sulfur, and other atoms. All right. So next, I think we should go on to write down the covalent bond. Okay. So anyone remember what is a covalent bond?
Once can you just revise it?
Aryan? Aryan, are you feeling sleepy?
Sir, just one yawning, sir.
So Aryan, what is a covalent bond? Okay, what is an ionic bond? Just tell me what is an ionic bond.
Sir, ionic bond is a bond, sir, in which, sir, they both are connected. What should I say, sir?
We studied about the ionic bond in metals and non-metals.
Yes, sir. Wait,
Okay, see. Can anyone tell what is an ionic bond?
Sir, ionic bond is when two elements combine by sharing of electrons.
No, not by
I,
sharing of electron. Ionic bond is the bond formation between two ions. Remember, ionic bond, a very simple thing. Ionic bond, it is the bond formed between two ions. Now, what are the ions then? So it is bond formed with two ions. So the bond formed with two ions is called as an ionic bond. Now, it simply states that two ions means they have to be positive and negative charges, and the electrostatic force between the two charges, it holds them together. So since they have the charges, that means they are formed by the complete transfer of electrons. So here you can add one more thing, that they are formed by complete transfer of electron. The ionic bond, it is the bond which is formed by the complete transfer of electron. For example, if we consider this sodium and chlorine and we represent their electrons with the help of a dot. So sodium atom has one electron, whereas chlorine atom has 7 electrons. Now to form the bond between the two, the sodium must donate one of its electron. So if sodium donates one of its electron to chlorine, you will have your sodium ion Na plus, you will have the chloride ion Cl minus. So the two ions, now they are held together with the strong electrostatic forces of attraction between the two. So because of the strong electrostatic forces of attraction between the two, these two ions are held together, which is the ionic. Got it? The next, so we have studied the properties of the ionic bonds. Like ionic bonds, they are very strong. They have the compounds with ionic bonds, they have high melting and boiling points. Right? So just after this, we'll start with the covalent bond. So in the next class, we'll be starting with covalent bond. We'll see again. Thank you and bye everyone. Don't just give. Okay, so thank you all those who kept their cameras on. All right.
thank you, sir. Bye.
thank,
Thank you,
have a
sir.
good
Bye,
day.
sir.
Yeah, covalent bonding we'll see in the next class. We'll see.